Okay, so this is for dynamics, okay, from dynamics compilation. So this was question 7. Okay, so slab M1, M2. So M1 is 40 kg, M2 is 10 kg. So it's rests on top of the slab, and the friction of coefficient of static and kinetic friction is this and this respectively. It's pulled by horizontal force so that they'll both move together. There is no slipping. No slipping, we'll be using coefficient of static friction. Okay, because kinetic friction is when the two surfaces are sliding. So we'll be using coefficient of static friction. So what happens is that they will move together, they will accelerate together. Now, if you draw the free body diagram on the M2, the 10 kg, okay, there will be forward force F and friction backwards. And by Newton's third law on M1, there will be a forward force. So this is our M2, which is 10 kg, this is M1. Okay, so this friction, the largest friction, the maximum, because we want the maximum possible F, so the friction will be at its maximum also. This will be mu n. Now, between the two, okay, there will also be an n that is like upwards and downwards. Of course, there's also a weight, okay, mg and m2g here and m1g here. Okay, yeah, there are probably more things here. Okay, here is probably m1g, and at the same time, there's another n from the floor. Okay, so there are more forces acting on it, but the acceleration is going to be leftwards. That's why I consider on the leftwards direction. But because of the static friction, the coefficients of friction, we still need this n. Okay, so the maximum value of friction is going to be mu n, mu static friction n. Now, so you'll be taking 0.6 multiplied by the n, which is going to be the mg, so 10 times 9.81. Okay, and this will give you 58.86. Now, in the older Olympiad, they use 9.80, so there will be some slight changes, definitely. Okay, so now we know the maximum friction. That is the friction that is going to accelerate M1, but we don't get the F yet. Okay, although I see 58.8 at C, but that's not the answer yet, so don't get tricked there. So our acceleration is equals to F over M1. So you'll get 58.86 divided by 40 kg, and you'll get, press on calculator, you get 1.4715. So finally, back to the first free body diagram. F minus F equals to M2A. Okay, M2 is 10 kg. So the force F is equals to 58.86 plus 10 times 1.4715. And this gives you 73.575. Okay, again, the older Olympiads, they use 9.80, so you'll get nearer to 73.5. So that's why answer is B. Okay, so this is for the first question. Okay, if you use 9.81, you'll get 73.6. That's why. Okay, if you change this back to 9.80, you can check that you'll get 73.5. Okay, let's go to the second question. Now, for this question, 2009 question 3, also dynamics. Spring balance is hung from the ceiling, and an inextensible rope is attached to the hook, the ground. So it's pulled tight so that it reaches 1 Newton. So it's then anchored to the ground as shown, and the object with weight 5 Newton is now hung on the hook. What will the balance read? In other words, what's the tension? So in this case, the tension here is going to be 1 Newton. Okay, so when you hang this thing here, it just reduces this tension. Just imagine there's a tension rope pulling here. Okay, it's already pulling it down. Now, if you pull down by 0.1 Newton, this tension here will slacken by 0.1. It's an inextensible rope. You put 0.5 Newton, you'll slacken by 0.5. If you put 1 Newton, the tension here will be 0. Okay, the tension at the ear will be 0 already. So you are just slackening the rope only. Nothing very special. Just imagine that. Okay, so unless this weight is more than 1 Newton, okay, then the string will probably totally slacken, because this will count extension. Okay, so because of that, right, when you put in the spring balance will still read 1 Newton. This is nothing. This is just more of a common sense thing. Okay, so that's the second question. Third question. 2010, question 31. Ball of mass 0.25 kg is thrown with a speed of 30 meters per second. It strikes a bat, hit back along the same line at a speed of 50 meters per second. So the variation of the force is given. Okay, and it's an isosceles triangle. What's the maximum force exerted by the bat on the ball? Okay, so what happens is that they want to find this maximum force, F max. Okay, now area under a force time graph, I think I mentioned before, is the change in momentum. So we need to find that change in momentum first. Okay, so this change in momentum here is the area under the graph, half F max times 8 milliseconds, 8 over 1000. Okay, so this is going to be 0.004 of F max. So that is the change in momentum. Now, at the same time, it's thrown with a speed and strikes back at 50. So it goes with a speed of 30 meters per second. Okay, this is the wall, or maybe not the wall, the bat, and it bounces off at 50 meters per second. So from here, the change in velocity is actually 80. The change in momentum is also going to be 0.25 times 80 because the mass is constant. Okay, so normally we just put the mass constant, we just take the mass out with time change in velocity. This will give us 20 Newton seconds. So 20 is equals to now 0.004 of F max, which is what we found earlier. Okay, 0.004 F max. So you can find the maximum velocity, maximum force, which is 20 divided by 0.004. Okay, and you get 5,000. So the answer is B. Okay, next one. 2011, question 8. 8-gram bullet is shot into a 4 kg block at rest on a frictionless horizontal surface. The bullet remains lodged in the block. So it moves towards the spring and compresses it by 9.4 cm. The force constant is this. What's the initial speed? So now we need to reconstruct the whole situation. So there's a bullet, goes into a block, which at rest at the start. Okay, initial. So this is the V that we need to find. So there will be then conservation of momentum. Then now the bullet and block system continue moving. Okay, maybe I let this be U, initial speed, and then this be V. Okay, it's a perfectly inelastic collision. And then they go into a spring and compresses the spring and come to a stop. Okay, so at this portion, there's a loss in KE, which is half mv squared, which is equal to the gain in EPE, half kx squared. X is 9.4 cm. So let's cancel the half, make it easier. The total mass is going to be 4.008. Okay, because 4 kg plus 8 grams. 8 grams 0.008 kg. So V squared equals to K, 9.4 over 100, 9.4 cm, convert to meters. Okay, so you find a V. So 1,000 times 9.4 divided by 100 squared times 1,000 divided by 4.008 and then square root, you'll get 1.484786. Okay, 1.4848 meters per second. Okay, so that is the velocity of the block bullet system just before collision with the spring. Okay, we assume no friction, nothing. Okay, no air resistance, nothing. So now, so this is the final. So now we then apply conservation of momentum. So this is the initial and this is the final for the conservation of momentum. So with the initial momentum, it's going to be 0.008 U, and the final momentum is equals to 4.008 V. Okay, because this is a perfectly inelastic collision. Okay, so now we can get our initial speed times V, which is 1.4848 divided by 0.008, and you get the initial speed as 743.9 meters per second. 2SF 740 meters per second. So answer is B.